Alright, for this lesson we're going to be graphing sine and cosine functions. Your graph will look a little bit different than when we did lines and parabolas. Your equation will look like this. Y equals some number sine, some number x minus something, a radian, plus some number. So you still have a y and an x in your equation. So here's what all of these things mean. When there is a number in front of the sine or cosine, that stands for amplitude. Okay, down here I have amplitude, tells you how tall or short a graph is. Okay, and sine and cosine graphs are all going to look like a wave, a continuous wave that keeps on going. Okay, up, down, they look like that. So your amplitude is the distance from your center line to the very top of your curve. So the other way to define amplitude is half the distance between the highest and lowest point. So here's the highest point, here's the lowest point. So if you added all that, the amplitude is half the distance, which basically is from your center line to your high point, or center line to your low point. Okay, if you have a number after sine or cosine but before your x, that number tells you have a period change. Okay, period change tells you how skinny or fat your curve or your graph will be. The period will be 2 pi times the reciprocal of that number. So you take the reciprocal of that number, multiply it by 2 pi, that's your new period. If you have been given the period and you want to find the coefficient, in other words, you've been given the period and you want to find what this number is, then you take the reciprocal of the period, multiply it by 2 pi, and that will give you the coefficient. Okay? If you have a number out here that's being added or subtracted, not inside the parentheses, but outside the parentheses out here, that T stands for translation. Translation will move your whole graph, your whole curve, up or down. If it's a positive number, it moves up, it translates up. If it's a negative number, it translates down. This number right in here, if there is a number with x plus or minus something in parentheses, that stands for phase shift. Okay, the phase shift will move your whole curve left or right. Okay, and here's the tricky part. If this is a negative number, a negative sign here, your whole graph moves to the right, and if it's a positive, it moves to the left. Okay, it's opposite of what we think. So when you're making your graphs, my recommendation is to do these in this order. In other words, if there's a period change, do that first. Then if there's an amplitude change, then do that. Then do your translation, then do your phase shift. So all of these apply to sine and cosine graphs. They will also apply to cosecant and secant graphs when you get to that lesson. And these also apply, all of these terms also apply to cotangent and tangent graphs as well. Okay, we're looking at 23C2 first, but the first thing I want to point out is what your graph looks like. Okay, this looks like x and y axis. The one thing I want to point out is that your y axis looks very similar to what you're used to. There's numbers, okay? Positive up here, negative down here. Your x-axis, instead of regular numbers, these are radians, okay? And so this is still 0, 0 at your origin. Pi over 2, you have to be able to convert that into degrees, okay? So pi over 2, that converts to 90 degrees. Pi, 180 degrees. 3 pi over 2, 270 degrees. 2 pi, 360 degrees. Okay? So you need to be able to think about what these are in degrees. But I'm also going to show you how to graph these just by changing your graph and not by plugging in numbers. Okay? So the first thing to look at, okay, here is the general equation of what your equation could be. Okay? Our equation is y equals 2 sine x minus 1. The first thing that I'm always going to tell you to do is to graph basic sine or basic cosine. In other words, what do I mean by that? Graph y equals sine x, just your basic y equals sine x curve first. Always do that. Always do cosine or sine first. So since this is sine, we're just going to graph y equals sine x. In other words, let's start here at the origin. If I put in 0 for x, if I'm at 0, sine of 0. What's sine of 0? 0. Okay, now let's get over here to 90 degrees. Put in 90 degrees, which is pi over 2. Put in 90 degrees right here for x. Sine of 90 equals 1. So when x is 90 degrees, my y value is 1, so I'm up here at 1. Now go to pi, which is 180 degrees. Put in 180 degrees right there. Sine of 180 degrees, 0. So at 180 degrees, you're back here at your y value is 0. Okay, now put in 270. So in your calculator, you can put sine of 270 degrees. That should be negative 1. So your y value is down here at negative 1. Put in 2 pi, which is 360 degrees, which is the same thing as 0. Sine of 0, or sine of 360 degrees, is 0. So you're basically putting in these main values, and you will see that your sine curve, your basic sine curve, looks like this. It will start at 0, go up to 1, go down to 0 at pi, go down to negative 1, and then come back to 0. Okay? And it will continue to do this pattern of up, down, up, down. It's called a continuous curve, meaning if I drew a line, my pencil would never come up. Okay? Also, domain and range. Domain is your x values. My x values can be anything because I'm going to keep going this way and keep going this way, meaning I can have any x value. So your domain is all real numbers. Your range is your y values. Well, you will see your y values only go from 1 to negative 1. They can only be between 1 and negative 1. If you just do your basic y equals sine x, you will never have a y value higher than 1 or smaller than negative 1. Okay? So if you graph your basic y equals sine x first, and I draw a dashed line because that is not my final answer. So if you always draw these 1, 2, 3, 4, 5 dots of your basic sine, then you make changes from there. This is your basic sine. Now let's look at my equation that I have, and let's make changes with that. The changes compared to this one. So you can see here I have a number in front of sine. The number in front of sine, that's this, that's A, that's amplitude. Meaning my graph is going to be taller or shorter than what's originally here with your basic sine. This number out here, when you have a number added or subtracted way out to the right, that's translation. So I have a translation change. Translation tells you your curve is shifting up or down. Well, since it's a negative, that means I'm shifting down. Okay? And remember I told you to do them in the order that I listed them. So the first thing that I listed was a period change. Period means the number right after sine or before x. The number right after sine or before x is an implied 1, which means there's no period change. I don't have to do anything with the period, okay? For basic sine, your period is, when does it start repeating itself? Sine starts at 0, goes up, goes down, comes back to 0 at 2 pi. So the normal period for basic sine is 2 pi. It goes from 0 to 2, it goes through one cycle, up, down, and 2 pi, because now from this point it's going to start repeating itself. So this is one whole cycle, so 2 pi. There's no period change, so it'll always stay from 0 to 2 pi for my new curve, no period change. So the second thing that I listed down was amplitude, okay? This number here in front, this tells you the amplitude. So this tells me, this 2 tells me that the height of my curve from my center line to the tallest point needs to be 2. So you can see that this x-axis is my center line, okay? This right here, this distance is my amplitude. From this center line to this highest point is a distance of 1. My amplitude is 1 right now for this curve, which makes sense because that's this graph. There's a 1, an implied 1 in front of the sine. My new amplitude needs to be a 2. So this distance now needs to be 2. So it needs to go from here all the way up to 2. So I usually switch colors. So this dot needs to now be moved up here for my graph to make my from here to here be an amplitude of 2. This point, and this point should not change. From here to here is a distance of 1 because I'm going down negative 1. This is my center line. So if I draw this here, this distance from the center line down is 1. one space, but I need it to be 2 because that's what this number is telling me. I need to have an amplitude of 2, meaning the distance from my center line to my high or low point needs to be a 2. So this dot needs to be moved down to here. Well, now I can connect my dots. These 0 points, what I like to call them, didn't change. So those 0 points stayed the same. And so now I draw that dashed line. Actually, I usually draw them dashed, but I'm going to try to draw it solid down so you can see it on the camera. Okay? So now that pink line included this amplitude change. Okay? I'm not done. That's not my final answer. Because now the next thing on the list was translation. This number way out here, adding to the right or left, is translation. For this problem, I don't have anything in parentheses, so there's no phase shift, meaning this curve is not going to shift to the right or the left. But this number way out here tells you it's going to shift up or down. Well, it's a negative, so that means it's going to shift down 1. So what you need to do is take every dot, all those 5 dots. You should be moving 5 dots. You should be, when you have to move dots, you look to see and you move these 5 dots every time. So this tells me the whole curve needs to come down 1. So I take this dot and I move it down 1. I take this dot, because this is where I'm at next, and move it down 1, which is back right there. You have to keep up with all this. I take this dot and I move it down 1. I like to do my graphs this way instead of plugging in numbers every time. In the book, they will plug in numbers, but I just like to change my graph. So I took this, shifted it down to 1. It was at -2, now it's at -3. Take this, which is at 0, shift it down to -1. And so now, connect all these dots. Then I truly recommend labeling, drawing an arrow, and then labeling that this is your final answer. If you label it, it will make it much easier when you check your answers in the back of the book, because you're going to have so many lines on here that now you know which one to look at to check your final answer. So this graph is the graph for y equals 2 sine x minus 1. We started out with basic sine of your black dashed, then we made the amplitude change, then we made the translation change, and this green one is your final answer. Okay, let's look at 23b3, y equals cosine 2x. Okay, we haven't done basic cosine, so let's just do basic cosine. So that would be y equals cosine x, with everything as a 1 in there. Okay, so putting in 0 right here for x, cosine of 0 is 1. And I've got these memorized, and if you don't, put them in your calculator. Okay, now we're going to do pi over 2, which is 90 degrees. Putting in 90 degrees, cosine of 90 will come out with a 0. So when you put in 90 for x, you get 0 for y. Okay, now put in 180 degrees. Cosine of 180 degrees will be y, your y value is -1. Now 270, you're going to be back at 0. And then 360, which is the same as cosine of 0, you're back up here at +1. Okay, so this is your basic cosine. My pen is running out because I'm... Okay, so here we go. There is your basic cosine, okay? Starts at 1, goes to 0, goes down to -1, back to 0, back up at 1, and then it'll repeat itself, okay? Once it starts repeating itself, it's gone through one cycle, now it'll start repeating itself. So, it went through one cycle from 0 to 2 pi. So again, the normal period for cosine is 2 pi, okay? The domain, same thing. If you just kept drawing this, the domain, your x values can be anything, but your range, your y values, go from 1 to -1. So sine and cosine both have, for just your basic cosine and basic sine, your domain will be all real numbers and your range goes from 1 to -1, okay? But now we'll start switching it up. So that was your basic cosine right here. I always recommend graphing basic cosine first. So now we only have one change. There is a number right here. Okay, the first thing, if you go by the list, the first thing you look at is period change. Well, where's the number for period? Right here after the word sine and before the letter X. Well, yes, we have a period change because here in basic cosine there's an implied 1 there. Okay, well now I've got a period change, I've got a 2. So I've got to figure out the new period for this equation of what we're trying to graph. We're now trying to graph that. What is my period for this? Well, if you look at the notes that I told you, it says the period. To figure out the period is 2 pi times the reciprocal of this. What is the reciprocal of 2? 1/2. So 2 pi times 1/2. This is like over 1. What happens to your 2's? They cancel. So your new period is pi. What this tells you is that cosine will go through this, starting here, go through the down motion and back up to 1 in a period of pi, from 0 to pi. It will go through one cycle. The period tells you how skinny or fat this is. In other words, we go from here to here in 2 pi. Now we want to do that same motion, go down and up in pi. So we've just squished our graph and made it skinnier. Sometimes your period might be longer, it might be 4 pi, and so what you've done is you just drawn it out and made it fatter. So I like to use the words how skinny or how fat. Okay? The amplitude tells you how tall or short, the period tells you how skinny or fat. So when you take this whole curve and when you squish it to where it goes through the down-up motion in pi. So in other words, I'm going to switch colors. So in other words, we want to start here. We didn't change the height of this, so it's going to still start at 1. We didn't change anything of that. And then we want it to end here. It's going to go down and back up in pi. Okay? So if it starts here, goes down somewhere and back up, we know it's got to end right here too, because if you look, cosine starts and ends at 1 when there's no other, when we're just dealing with the period change. Okay? Now we want to start here, go down and back up and end at pi. Well, now we've got to figure out where our low point is. Well, basic cosine, your low point will be halfway. Here your basic cosine starts at 0 and goes to 2 pi. Your low point will be halfway in between. Well, what's halfway in between 0 and 2 pi? Pi. So that's my low point. So now here I'm going to start at 0 and go to pi, so my low point needs to be halfway in between. I like to just count the tick marks. 1, 2, 3, 4. Halfway point would just be 2 tick marks. 1, 2, right here, pi over 2. That way I don't have to worry about, okay, what's half of pi? I mean, granted we could all say pi over 2, but you can just count tick marks. Okay, like if I said 2 pi, 1, 2, 3, 4, 5, 6, 7, 8 tick marks. Well, halfway would be 4 tick marks. 1, 2, 3, 4, and there you go. My low point is halfway at the 4th tick mark. So here, this is 1, 2, 3, 4 tick marks wide. So my low point needs to be halfway, which is at 2 tick marks. And the low point did not change as far as the height. It's still at -1. So there's my low point. Well, then these 0 points, this point at 0 was halfway between this high point and low point. That 0 point is halfway between that low point and high point. So therefore, my places at 0 will be halfway between this high point and this low point, which will be right there. That's 2 tick marks, so the halfway point will be 1 tick mark, which means this halfway point will be right there, halfway between that low point and that high point. And so, there you go. I have just done the period change. There's no other changes in that equation. The only thing that changed was the period. There's no number in front of my cosine. There's no numbers added or subtracted out here. So the only thing that got changed in this equation was the period. So that would be your final answer. And again, it's very, very important to mark these final answers. That way you know what your final answer is when you go to check it, and then you're used to doing this when it comes time to take a test, so that whoever is grading your test will know what the final answer is. Because if you turn in a test and have these two graphs on here and it's not marked, no one knows what your final answer is and they can't mark it correct. So it's automatically wrong. Okay, we're looking at 23C number 4. Here is our equation. It's sine. So, of course, I'm always going to graph basic sine first. When I say basic sine, I mean y equals sine x. Okay? So, Eventually, you'll just have these down memorized, and you'll be able to say, okay, at 0, sine of 0 is 0. At 90 degrees, sine of 90 is 1. At 180, sine of 180 is 0. At 270, sine of 270 is negative 1. Sine of 360, which is same as 0, is 0. See, I've started here, and I've gone up, I've gone down, and I've gone through one cycle at 2 pi. Basic sine, you will always do one cycle at 2 pi because then it starts repeating itself. Okay? This is what basic sine looks like. Start at 0, up at 1, down to 0, down to negative 1, back at 0. Okay? So, now looking at our equation. Go through your list. Period change. Is there a number after sine and before the x? That would be right in here. No. There's no number here. That's an implied 1, which means there's no period change. Next thing on the list, amplitude. Number before sine. Number before sine, implied 1, which means there's no amplitude change. Nothing to do with the amplitude. So, in other words, this is not going to change how skinny or fat it is or how tall or short it is. Next thing on the list, translation. Is there a number added or subtracted outside parentheses? That would be out here. There's not. So there's no translation. Translation moves this whole thing up or down. Okay? But the one thing we do have in this equation is a phase shift. We have a number right here. We have x plus or minus some number in parentheses. So we have a phase shift. Phase shifts takes your whole curve, the whole curve, and moves it right or left. So we're going to take this whole curve. It shouldn't look any different than what it is now, except we're going to move it to the right or the left. So we need to determine, are you moving it to the right or the left? What we wrote on there is that when this is a positive sign, you actually move to the left. I will tell you why. Because your general equation has a subtraction sign here. You want a subtraction sign here. How do you get a subtraction sign here? X minus a negative pi over 4. So when this becomes x minus a negative, then becomes a positive. That number right there says negative pi over 4, which means you are shifting to the left. So when you put your equation in this form with a subtraction sign, if you have a subtraction sign, the number here just tells you a positive number and you move to the right. When you put a subtraction sign here and this number is a negative, you move to the left. So this is why when it's a positive, you move to the left, and a negative, you move to the right. I get it gets confusing. It's opposite of what we generally think of. So basically, this tells us we want to move our whole curve to the left, pi over 4. Well, how much is pi over 4? Every tick mark on here, if from here to here is pi over 2, then half of that, every tick mark means pi over 4. Because from here to here is pi over 2. Well, half of pi over 2 is pi over 4. So this actually would be labeled pi over 4, which means one tick mark represents pi over 4 on all of these graphs. Okay, so one tick mark is pi over 4. Because if I counted 1, 2, 3, 4, this would be 4 pi over 4, which is pi. 4 pi over 4 because I counted. So and those 4's cancel, leaves you pi. So every tick mark is pi over 4. So basically what I'm saying is you want to move this whole graph to the left one tick mark. If you can just get used to the tick marks, then you can just count tick marks, okay? So basically I need to take every dot and move it to the left one tick mark. I don't change the height of it. So this is at 0, so all I'm going to do is move it to the left one tick mark. Take this one, keep it at 1, and just move it over one tick mark. Take this one, move it over one tick mark. Take this one, scoot it over one tick mark. It needs to stay at -1. Mine doesn't look like it's at -1. Take this, scoot it over one tick mark. We only need to make a phase shift on this graph so we can make it a solid line. So that right there, that brown line, would be your final answer because that was the only change that we had to make was a phase shift. Okay, so now we're looking at 23D4. Here's your general equation, and just know that this word can either be sine or cosine. This also applies if it has cosine in it as well, okay? So we're looking at this equation, and if you look, we have a change of everything. We have, this is amplitude, that's a period change, a phase shift, and a translation. So we're going to be doing all 4 things. So really keep up with your colors and your graph. So what's the very first thing you always do? Graph your basic cosine or sine. Since this is a cosine, we're going to graph basic cosine, okay? Basic cosine at 0, if you put in 0 for x. Cosine of 0 is 1. Your y value would be 1. Essentially, it's like you're making this xy chart, okay? Cosine of 0 is 1. Now cosine of 90 degrees is 0, and so forth. So cosine of 90, your y value would be 0. Cosine of 180, y value would be -1. 270, you're back at 0. 360, cosine of 360 is back at 1, which is same thing as 0, okay? So this is your basic. Once you do one cycle, I stop at 2 pi normally because it's going to start repeating itself. It'll do this, it'll go up and start repeating itself, okay? So follow the list of what the next thing on the list is. The very first thing you always look at is period change, okay? This one does have a period change. This number right here represents your period change. How do you determine your period? Period equals 2 pi times the reciprocal. The reciprocal of this number. What's the reciprocal of 2? 1/2. 2's cancel, so your new period is pi. Meaning, cosine will go through this cycle of this down up in pi. In other words, we take this, it's in 2 pi right now, we're going to squish it to pi. Okay? So how do you do that? So this starting point won't change, but my ending point is going to go down and back up in pi. It'll end right here at pi. So the low point will be halfway in between these two. So that's 4 tick marks from there to there, so the low point will be down here at 2 tick marks. And then the 0 points will be halfway between this high point and low point, which this is halfway at this tick mark, and that's halfway at that tick mark. Okay? So that shows my period change. Okay? So now we're going to work from this pink curve. The next thing on the list is to do amplitude. Amplitude tells you how tall or how short. Okay? This number here tells you the amplitude. Okay? So from my center line, I want my distance to be half. 1/2 from my center line to my highest point. This x-axis right here is my center line. You can see, because from here to here is 1, from here to here is 1. So this would be my center line. Sometimes your center line might change, but right now this is my center line. So from here to my highest point is 1, but I want it to be half, 1/2. Well, how do I get the distance from here to my highest point to be 1/2? I bring this down 1/2. So if this point was right here, which would be at 1/2, then from my center line to here is 1/2. Same here. This has to come up 1/2. So if this is at -1/2, then from my center line down is 1/2 distance. Okay? Same here. From here to here is 1, but I only want it to be half. So this has to come down to my y value of half, if I put a tick mark there. Okay? So basically my graph just became shorter because my amplitude is smaller. Okay? These 0 points didn't change. When you're already at 0, then those points usually aren't affected, but I'm still going to use those. Okay? So I'm just going to draw over them so you know there's green dots right there. Okay? I'm not going to dash this one because it'll get lost. So right now we're working with this green line. Okay? The next thing that we need to change is on the list is translation. You always do phase shift last. Okay? Translation. This is this number right here, -1. It means I need to take that whole graph and move it down -1. I take this whole green thing and shift it down 1. Okay? So I want to take this dot and move it down 1. Well, it's at 1/2 right now. Well, to move it 1 whole space, from here to 0 is just 1/2. Then I move it down 1/2, which would be 1. Okay? From here to here is 1. Because from here to here was 1/2, and then here to here was another 1/2. Okay? Now this 0 is at 0, needs to be shifted down 1, which would put it at -1. This green one is at -1/2. Well, to shift it down 1 would put it at right here at -1.5. This one's at 0. To shift it down 1 would put it at -1. This one, shifting it down 1, we put it at -1/2. So there's that new graph. Now we work from the blue. Now the last thing we need to do is our phase shift, okay? Positive pi over 2. First off, you need to know how much is pi over 2. Well, if you're not sure, at some point you'll get these memorized, but pi over 2 is the same thing as 90 degrees. You don't need to know that for the phase shift, you just need to know how many tick marks is that, okay? Well, if you look from here to here, 0 to pi over 2 is 2 tick marks. 1, 2. So we need to shift everything 2 tick marks. We need to know, do we shift right or left? When this is a positive, you shift to the left because it has to be in the form with a subtraction sign there. Well, in order for that to be a subtraction sign, that means this has to be a negative pi over 2. Negative, negative becomes a positive. So this negative tells you you shift to the left. Left pi over 2. So we're taking this whole graph and shifting it to the left 2 tick marks because pi over 2 is 2 tick marks. So I'm going to take this point and go 1, 2. Make sure you keep it at the same height on the graph. It's at -1/2 here. It needs to be at -1/2 here. This goes 2 tick marks. That would be 1, 2. This goes 2 tick marks. 1, 2 on the y-axis. This goes 2 tick marks. 1, 2, which would be on top of that blue dot right there. This goes 2 tick marks. 1, 2, which would be on that dot right there. You're going to have to just keep up. So this, and I usually just draw one cycle. You can keep going and draw more cycles. But when you check your answer, you can look at pi over 2, you should be at -1/2. Or at negative pi over 2, you should be at 1/2. This would be negative pi over 4, should be down at -1. On the y-axis, you should be down here at -1.5, and so forth. These are the points you can check to see if you've got your answer correct. And then label that as your final answer. Okay, we're doing 23D3, and we've got this equation, and there's an amplitude change, a period change, and a phase shift. So the only thing we don't have in this equation is a translation change, okay? So we're dealing with sine, so graph basic sine first. So sine starts at 0, goes up at 1 at 90, goes back down to 0 at pi, down to -1 at 270, and then back to 0 at 360, okay? So I'm going to draw that as a dash because that's not my final answer. And now I'm going to work on changing colors. Okay, so look at your list. The very first thing you always do is a period change. Okay, this number after your sine, before your x is your period change. This is our period change right there. Okay, period equals 2 pi times the reciprocal of this. What's the reciprocal of 1/2? 2. So 2 pi times 2 equals 4 pi. My new period is 4 pi. In other words, it will, right now, it goes its whole cycle, one whole cycle, up, down, and back up in 2 pi. Well, we wanted to do this up-down cycle in 4 pi. So we are basically stretching this out. We're making it fatter. So it's going to start at 0 here, and we want it to end at 0 at 4 pi, just like it starts at 0 and ends at 0 at 2 pi. Well, now we want to start at 0, so that's going to stay the same. We want it to end at 0 at 4 pi. Okay? So it's going to do its up, down, and back up to here. Now we've got to figure out these spaces in between. How I like to do it, where's your halfway point for sine? Halfway point for sine is this other part, this other dot where it's at 0, okay, on the axis. This is halfway. There are 8 tick marks. This is at the 4th tick mark. This is your halfway point for sine. So I need to find my halfway point. Where's halfway between 0 and 4 pi? At 2 pi. Well, since it's at 0 here on the axis, then at 2 pi, I will have a point on the axis. So now I've got my 3 points, but now I've spread them out. So now I need to do my high point and my low point, okay? My high point is halfway in between these. So it'll be halfway in between these new points. Well, what's halfway in between 0 and 2 pi? Pi. So my high point will be right here, and that value of 1 didn't change. Mine looks higher, but it's still at 1. Okay, now I need to figure out what this low point is. Well, this low point will be halfway between here and here, because right now it's halfway between these two. So now it's going to be halfway between my two new points. So halfway between 2 pi and 4 pi will be 3 pi. So this low point still at -1. Okay, so I did that period change. So it's going to run this whole cycle in from 0 to 4 pi. That shows you the graph of the period change. Okay, now let's do next on the list. Next on the list is amplitude. Okay, amplitude, this number tells you the amplitude, 2. So, in other words, we want from our center line to the high point or to the low point to be the distance of 2. Right now, here's my center line, which would be the x-axis. My distance from high point to low point is a distance of 1. From the center line to the high point is 1. From the center line to the low point is 1. I want it to be 2 because that's what the amplitude tells you. The amplitude is the distance from the center line to your high point. So I want the distance from here to my high point to be 2. Well, how do I get that? I need to move this up to 2. Because if this is the high point now, from a center line to here is 2. I want that to be a distance of 2. Same with this, my low point. Right now it's only a distance of 1. Well, how do I move it to be a distance of 2? Scoot this down to -2. So now from here to here is a distance of 2. My 0 points didn't change at all. All your amplitude does will tell you how skinny or how fat, how tall or how short. Not skinny or fat, but how tall or short. So we just basically made this taller. My amplitude is higher, it will be taller. So there's my new graph with the amplitude change. Now the only thing that I need to do is my phase shift. Okay? When this is a negative, means I move to the right, because this means x minus. You want this to be a negative, so you use the number right here, pi over 4, which is a positive pi over 4. So we want to move to the right, pi over 4. Pi over 4 is 1 tick mark. Okay? So now we basically take all of our points, which we're still using these right here, the 0 points, and we move all of them over 1 to the right. So take this point, move it 1 tick mark to the right. Take this, move it 1 to the right. Take this tick mark, move it 1 to the right. Take this tick mark, 1 to the right. You got to remember which graph you're working with. And this tick mark, 1 to the right, which would be right there. So this brown is actually my final answer after doing all of those changes. Okay, so now we're looking at 23B10. On this problem, they're actually giving you the graph and you have to come up with the equation for it. They tell you if it's sine or cosine. For this specific problem, it's a sine, so we know it's going to be y equals sine something. So we have got to determine the amplitude period, if there's any translation changes or phase changes according to the graph. My recommendation is you should be able to look at the graph first to see what the period is and amplitude is. Okay, so I still recommend doing them in the order that we listed. So the first thing is period. Okay, so this is sine, so it's going to go up and down and back up. And then when does it start repeating itself? It starts repeating itself at pi. It starts at 1, goes up, down, back up, and it looks like it ends at 1. You just kind of have to assume and do some guesstimations on some of these. It looks like it ends at 1 right around pi. Close enough. So we're going to say that this period is pi. Okay? So, because then it goes up and down and back up again in another pi. So, I know the period is pi, but I've got to determine, with that being said, what is the coefficient in my equation? Okay, and on your sheet we wrote down that the coefficient is going to be 2 pi times the reciprocal of this. This was 1 pi, okay? So the reciprocal of 1 is just 1, so that's times 1. And you can almost ignore the pi, because we don't say 2 pi times 1 pi. You're just saying times the reciprocal of the 1. That's a 1 in front of the pi. So we can ignore that pi. So 2 times 1 is 2. So your coefficient is going to be 2 in your equation, because for the period you don't have the the pi next to that, okay? So in our equation, the coefficient is going to be 2 in place where our period is, okay? So as a reminder, here's our general equation. So right here when we write our equation, in place of that, there's going to be a 2. That's for our period. Okay, now amplitude. The best suggestion I would say is look for your center line. Where can you be a center line? Well, I started here and then I ended here. So that looks like to me that would be a good center line. Okay, and does that work? Is the distance from here to here the same from here to here? Well, from here to my high point is 1, 2. From here to my low point, 1, 2. So that matches. So that means that this is my center line. Amplitude is this distance from here to here, or it's the same here to here. So that right there, my amplitude is 2. Okay, so now I can write down that I know my period is 2. My period is 1 pi, which means the coefficient will be 2, and then my amplitude is 2, which means that's the number we'll put in place where our amplitude is, right there. Okay, now to figure out if there's any translation or phase shifts, I recommend drawing the original basic sine to compare, okay? So if we had basic sine would look like this. Okay, that's my basic sine. Okay, now let's go through making these changes. Okay, so if I make this period change to this green curve, well then it's going to look like, it's going to be, let me use a different color. It'll be from here to pi, because my period needs to go from here to pi, which means that my middle point for sine will be right there, my high point will be here, my low point will be here. So all I did was took that green curve and then make the period change to 2 pi. Okay, now I need to make the amplitude 2 to this curve. Well, right now from here to here it's 1, so in order for it to be 2, I'd have to come up here. And then in order for this to here is 1 to be 2, it's got to come to here. So then to make that amplitude change, it looks like this. Well, my blue curve is still not matching up with what they have in the book. I need to make my blue curve match with what's in the book. Well, you can see there's no phase shift. I don't need to move anything to the right or the left to get this to match. I just need to take my whole blue curve and move it up in order to get this high point to match this high point, and to get this low point to match this low point. So a lot of times what you can do is you can look and see what the amplitude is and period by the curve. Then for your translation and your phase shift, draw your basic sine, then make those period and amplitude changes to it. Now determine how do you need to shift up or down or right or left or both to get your high points and low points to match. Well, you can see in order to get this high point to match what's in the book, I need to move it up 1, a positive 1. So same here, to move this up a positive 1. To move, if I moved all of these up a positive 1, then I will match the curve. So that tells me that I have a translation of a positive 1. Now that I know all that, I can write my equation because I don't have any phase shifts. So my equation will be y equals, my amplitude I said was 2. So 2 goes in front of my sine. I did say that there's a period change and my coefficient is going to be a 2. Y equals 2 sine 2x. There's no phase shift, so there's no parentheses. And then my translation is a plus 1. So this equation matches that curve.